Hey guys! So today we are working on variables on both sides, distribution, and we're working on page 157. So we're going to do some examples together, and I'm going to pick examples that are similar to your quiz questions. So that's good. Okay, let's start with number 2. So number 2, we have a variable on each side, and then we have our inequality sign. So think about our goal. Our goal is to get our variables on one side of our inequality, and then we want to get our numbers on the other side of our inequality. And it doesn't matter which way that inequality is, we just need our variables on one side and our numbers on the other. Okay, whether that goes this way or this way, it doesn't matter. All right, so here we go. I'm gonna move my x's to be together first. So I want to add 2 x's here. I want to make this side 0 and get rid of the x's on this side. So we're going to do the opposite of minus. So we add 2x to make that go away. Bring down your sign and bring down your 38. When I add 2 x's to this side, I have to add 2 x's to my x. So my 10x's get 2 more because they are like terms. So 10x and 2x make 12x, and then I still have this positive little 6 hanging out. And now I'm trying to get my x's by itself. I have a 6 and a 38, which are both plain numbers with no variables. So these guys are like terms. So I'm going to get rid of 6 on this side and 6 over here. So we're going to subtract 6 from this side and make that go away, leaving just 12x. And then I'm going to subtract 6 on this side. So 38 minus 6 is 32. And then we are going to get our variable by itself by doing the opposite of multiply, which is divide. What we do to one side, we must do to the other. Since I divided by a positive, I'm going to keep my sign the same way. My 12's cancel, leaving just x. And 32 divided by 12, we're going to do that here, is a decimal. 2.7. We're going to round. All right, so we are going to graph this. All right, we're going to put our most important number in the middle, so that will be 2.7, and it's a closed dot because I have the equal to sign underneath it. And then my alligator is not eating my number, so that means that my number is not the biggest, it's the smallest. So I want to shade all of the biggers this way. And then we're going to write our interval notation. So remember, the interval notation goes from left to right, just like we read. On the left-hand side, there's nothing shaded or no numbers, nothing important over here. My first important information is at 2.7. It's a filled-in circle, so we're going to give it a bracket. Then we put our comma, and then to the right forever and ever means positive infinities. Infinities always get parentheses. So this is my interval notation for that problem. Okay, let's try another one. We are going to do number 4. Love number 4. Here, now you can still see that one. Okay. On number 4, we are going to combine our like terms to start. On the left-hand side, we have a negative 3x and a negative x. When I add those together, negative 3 minus 1 is negative 4x's. I still have my 16, and it doesn't matter what order you write them down in. My inequality, 5x minus 8. Okay, so we want to get the x's together, or like get rid of the extra piece on each side. So I'm going to start by adding 4x over here because I want to do the opposite of what it says. So the opposite of minus is add. I'm making this 0, leaving just the 16 because I want the x's on one side and the numbers on the other side. And then I have to add 4x to this side of my inequality because it's kind of like an equation, but with a different symbol. 5 and 4 make 9x's minus 8. And now I need to take away the extra piece over here. So the opposite of minus 8 is add 8. What I do to one side, I must do to the other side. The 8's go away on the right-hand side, leaving 9x. On the left, I have 16 plus 8, which is 24. Then we want to get our 9 by itself, so we're going to divide each side by 9, which again is not going to be nice, which is fine. Decimals are fine. Or you can leave them as fractions. Okay, so again, 9 divided by 9. I'm going to keep my sign the same way because I didn't multiply or divide by a negative. And then I have 2.7 again. Okay, so let's graph this guy. Instead of being a closed dot like the other one, it's an open dot because I don't have a line underneath it. And then I'm not eating my number, so I can't, I should label it 2.7. I can't go to the left because 2.7 is not the biggest. It's small, so I need to go to the right. I want all the bigger numbers because we want this statement to be true. So if I pick a number bigger than 2.7, like, I don't know, 10, let's plug it in for x. Is 2.7 less than 10? Heck yeah, it is. So we want to shade on the side that makes this statement true. We could pick a smaller number if we wanted to, like 0. Let's test that. Is 2.7 smaller than 0? No. So we don't shade that side. Okay. Interval notation. To the left forever and ever, there's nothing highlighted, so nothing important. So our first important piece of information is our 2.7. So I'm going to write that down, 2.7. Since it's an open dot, we get parentheses, and then to the right forever and ever means positive infinity, and infinities always have parentheses. The positive infinity should always go on the right, never on the left. And voila, we're done. Okay, one more. We're going to look at number 7. Yeah, number 7. Cool. So on number 7, we have these parentheses. So we need to distribute the 2 to the 4x and the 3. Remember, distribute means multiply. So 2 times 4x's is 8x's, and 2 times 3 is 6, is less than or equal to 10. We're trying to get the variable by itself, so we want to get rid of this positive 6. The opposite is subtract. What I do to one side, I must do to the other side. I'm not going to be able to subtract x's here because I don't have any x's on the other side. So we keep our 8x. 10 minus 6 is 4. Then we need to get our variable by itself. It's getting multiplied by 8, so we're going to do the opposite, divide each side by 8. Since I divided by a positive number, my symbol needs to stay. And 4 divided by 8 is a half, or you could write 0.5. Or you could write 0.5, whatever makes you feel oh so happy. Okay, then we are going to draw our graph. This is part of our work so that we can see what's happening. Since I have an equal to line, we're going to have a closed dot. And I'm just going to write half because I like it. It's fun to write fractions. Okay, now my alligator is eating my 1/2, so that is my biggest. So I need to shade all of my smaller numbers, which are this way. To the left, to the left. Okay, so remember, to the left forever means negative infinity, and to the right forever means positive infinity. So I'm starting, when I look at this graph from left to right, I'm starting by looking at this shaded side. So the shaded side to the left forever and ever means negative infinity. And negative infinities always have parentheses. Then we're going to put our important number, and since it's filled in, it has a bracket. Okay, hold on. Okay, so just one more thing, guys. These are the problems for your quiz today. So you're going to do problem 6, 8, and 10. So just a few reminders. Be careful on combining like terms. If they're on the same side, you got to keep the signs the same. Number 8, be really careful. You have to distribute this cute little negative here and here. So be very careful about your signs. And then on number 10, remember, do not combine the 4 and the 2 first. Do not combine those. The first thing you should do is distribute this -2 to the x and the -2 to the 6. All right, guys, good luck. Bye.